In today's lesson, we are looking at taking the derivative of inverse functions. So let's talk about what is an inverse function. So we've kind of reviewed this a little bit. It's the idea of that switching x and y. So just some quick notation. If you have x to the power of -1, that is a reciprocal 1 over x. And then if we're dealing with trig functions, think 1 over sine of x is cosecant of x. So these are reciprocal functions, not inverse functions. Okay. Whoop. So inverse is when we're taking a function to the power of -1. So that's the difference. So when we're dealing with trig, it's sine the function to the power of -1. And if you maybe remember from pre-calc, inverse, when you are doing function composition, f of g of x, when they are inverses of each other, it always simplifies down to a single x, and it works both ways. G of f of x equals x. And in this lesson, you're going to be seeing this, where this is just basically saying the g function is the inverse of f. So now when you are taking the derivative of an inverse function, the derivative of an inverse function, it is equal to, you're going to have to memorize this, 1 over the derivative of f of the inverse of f. So this is kind of a weird thing, and it's this lesson can be hard to visualize dealing with the inverses, but we can do this. So just write this down and memorize it. We're going to be working with it. Okay, so here's an example. I'm going to make this statement up here that the function g of x is the inverse of f of x. So I have this f of x function, and then the g of x I'm stating is the inverse of this. And now f of 7 equals 2, f prime of 7, so the derivative of f at 7 equals -1. And the question is, I want to find the derivative of g at -2. So what is the derivative of g? Well, it's going to be the same as taking the derivative of f inverse, because g is the inverse of f. Okay, so every time I always write down that rule, 1 over f prime of f -1 of x. I just realized a mistake that up here I was supposed to make that a negative. So I'm going to input this -2 in here. So 1 over f prime f -1 of -2. So I'm putting this x value in, but because it's this inverse function, remember the idea of switching x and y? So f of -2, but this is f inverse of -2. So notice here, we go to the y of f, because the y of f is the x of the inverse, and the x that matches that up is the y on the inverse. So this right here equals 7. So 1 over the derivative of f at 7, and here the derivative of f at 7 is -1. So 1 over -1 equals -1. Okay, so that's a lot to wrap our heads around. Let's do this one more time. So same thing, I've got this statement right here. So that statement's important, that g of x is the inverse of f. And we're finding the derivative of g at point 1. So this x value on the g function, g is the inverse, so that is the y value here is actually the x value on the inverse. So I'm going to write this down again. 1 over the derivative of f of the inverse of 1. Okay, so the inverse at 1. So on the inverse, this is the x, so this is the y. So the inverse of f at 1 is -5. So 1 over the derivative of f at -5. And the derivative of f at -5 is 6. So 1 over 6. Okay, so changing it up a little bit, but still starting with this statement that the function g of x is the inverse of f of x. Okay, this time I'm going to give you this function f of x is equal to the square root of 4x plus 4. And we are going to find the derivative of g at 6. So I'm going to write this down, the 1 over f prime of inverse f at 6. Okay, so starting out, if this is x on the inverse, it's y on the original. So instead, I'm not plugging in 6 for x, I'm plugging it in for y and finding the x. So 6 equals the square root of 4x plus 4. So I'm plugging in 6 on f and finding x. Finding this x is actually finding the y on the inverse function. So that concept is kind of difficult to visualize, but I'm going to solve for x here. Square both sides, so 36, subtract 4, so x equals 8. So this is f of 8 is 6. So then the inverse of f at 6 is 8. So that's this first part that we have to evaluate. So 1 over the derivative of f of 8. So now we have to find the derivative of f and plug in 8. Okay, so I rewrote f of x instead of a square root with the power, and I'm going to find the derivative of f using power rule, chain rule. So this is 1/2 times 4x plus 4 to the power of -1/2 times 4. This 4 times 1/2, so there's 2. So I'm going to rewrite this as 2 over the square root of 4x plus 4. So then the derivative of f at 8. So 2 over 4 times 8 is 32, plus 4 is 36, square root is 6, so it's 1/3. So go back up here, 1 over 1/3 is 3. So let's just do a recap here. F of x, g prime, so derivative at 6. So we first, looking at inverse, we plugged in this x, but we plugged it in for y, solved for x, because this x is actually the y of the inverse. And then we had to take the derivative and then plug in 8, but we have to, I always forget to then, after I get my answer here, to then go back and do 1 divided by that. Okay, we're going to go through this process one more time. Okay, so this statement is important. So g is the inverse of f. So when I'm finding the derivative of g, I'm finding the derivative of f inverse. Okay, so I'm going to write this down. 1 over derivative of f of inverse of f at 1/3. Okay, so to evaluate the inverse of f at 1/3, okay, that's an x value, but inverse, I'm actually plugging it in for y on the original f function. So 1/3 equals 1 over 5 minus x. I can cross multiply. So 5 minus x equals 3, negative x equals -2, x equals 2. So x equals 2 on the original function, but that's y on the inverse function. So f -1 of 1/3 is 2. So 1 over the derivative of f at 2. So now I have to find the derivative of f. So I rewrote f as that 5 minus x, but to the power of -1. So then taking the derivative, I can do the chain rule. So -1, 5 minus x to the power of -2 times -1. So I'm going to rewrite this, two negatives, that's going to be positive 1 over 5 minus x squared. And then I want, let's see, the derivative at 2. So derivative at 2, 1 over 5 minus 2 squared. So that is 3 squared is 9. So this is 1/9. So this is 1/9. So I still have to do 1 divided by 1/9, which is 9. So I'm going to recap one more time because I just think it's helpful. So we go up here. I have this f function. I want the derivative of g, so the derivative of this inverse. So I use this formula. This x value on the inverse is the y value on the original. So I plugged in for y, solved for x. This x is the y on the inverse. So it went in here. And now I have to do the derivative. So I had to find the derivative and plug in that 2, and then plug that back into this formula. So inverse functions, it's just a lot to think about. But there's your full lesson, and we'll work on the assignment together in class. Good luck.